Hello boys and girls, here we're going to do lesson 11.4 and we are going to find the surface area of a pyramid. So our objective today is I can find the surface area of a pyramid. So by the end of today's lesson you should be able to do that. Now remember, a pyramid has one base and then it reaches up to a single point. I always think about the pyramids in Egypt like this picture we have here. Okay. Oh, there we go. You'll notice here's the base. This is a square or rectangular pyramid, and then they all reach up to a point. Alright? Now notice the shape of the base, and that is the name of your pyramid. So for example, if the base was a triangle, it would be a triangular pyramid. If it's a rectangle, it's a rectangular pyramid. If it's, say, a pentagon, it's a pentagonal pyramid, so on and so forth, okay? And as you fold it, it comes up into a point. Now, just a reminder, these sides are called our lateral faces, and in a rectangular pyramid there are 4 lateral faces. You can't see this one back here. There's one on the back side of here as well. In a triangular pyramid there are only 3. In a pentagonal pyramid there are 5. In an octagon pyramid there are 8. Okay, so there's as many pyramid or faces as there are sides of the base. Okay, so here's our first example. Please write these problems down in your notebook. Coach Beathers is building a model of the Egypt pyramids. Remember, she loves Egypt. The base is a square, see my net, with side lengths of 12 inches. Each triangular face has a height of 7 inches. What is the surface area of her model? Now, I want you to pause your video and go ahead and write down the problem and draw this net. Go ahead and pause now. Okay, so the first thing I like to do is I like to find the area of our base. So going back to our problem, we're looking to see if it tells us how long the side lengths of the base are. Let's go back and read it. Coach Beathers is building a model of the Egypt pyramids. The base is a square with side lengths of 12 inches. Perfect. So I have 12-inch side lengths. So I'm going to switch colors here. In my net, each of these side lengths are 12 inches. Okay, so I'm going to label it first. Now I'm looking to see if it's going to tell me the height of the triangles. Oops, that's kind of weird looking. There we go. Show that it's the right angle. Let's read again. Coach Beathers is building a model of the Egypt pyramids. The base is a square with side lengths of 12 inches. Good. Each triangular face has a height of 7 inches. Perfect. That's exactly what I needed to know. So each of these triangles, the height is 7 inches. Abigail, calm down. Okay. There we go. So we'll finish labeling all of it. And then, of course, I need to make sure I know what it's asking me. It says, what is the surface area of her model? So I need to find, sorry, Abigail is chasing her tail. I need to find the area of the base, and then I need to find the area of one triangle and multiply it by 4 to come with the surface area of the whole triangle. So let's go ahead and get started on that. To find the area of the base, I need to do length times width, or base times height. And it looks like I have 12 times 12, because it is a square. 12 times 12 is 144. Now, remember, to find the area of a triangle, one of my faces here, it'll be base times height divided by 2. So my triangle base is 12, right here. My height is 7. I'm going to divide that by 2. 12 times 7 is 84. 84 divided by 2 gives me 42. So, each triangle has an area of 42. What are we looking at? 42 inches. 42 inches squared. So I have 42 inches here, 42 inches here, 42 inches here, 42 inches here, and then 144 inches in the center. So I need to add all of those together. I'm going to do 144 plus, and then I'm going to do 42 times 4 in parentheses, because I want to do that first. So 42 times 4, do that on the side, gives me 8, and 4 times 4 is 16, or 168. Then I'm going to add that to my 144. I always rewrite these numbers because it's much easier up and down like that. 2, good, got 312. Perfect. Now for surface area, it looks like we're doing inches squared. And there's my answer. Okay, so just a quick review. I found the area of the base using the measurements in the problem. I found the area of the triangles and used my formula, base times height divided by 2, and then I multiplied it by the number of faces that I had, and added my faces and my base, and it gave me 312 inches squared. Okay, please raise your hand if you have any questions on this one. If not, then go ahead and move on to the next problem. Okay, I'm going to go ahead and teach you a new word. This is called, so we've been working with surface area, but this is called the lateral area. And it is the area of just the faces on a pyramid, not the base. Now let me tell you why you would need to find the lateral area, why that's important. So, for example, if you're putting solar panels on a pyramid-shaped building, like the one in this picture, see this building? If you're going to put solar panels on there, would you need to put them on the bottom or the base? Think about it. The base is sitting on the ground. No, you don't need to put solar panels on the base. You just need to put them on the sides of the faces. So this is called the lateral area when you're just finding the area of the faces and not the base. Okay, so some problems will ask you to find the lateral area, some will ask you to find the surface area, which includes the base, and some will not specify, and you'll just have to think about what it's really asking you. So make sure you write down this definition. Alright, so here's an example of when we're going to look for the lateral area of a shape. So the example says, Mr. Twisdale is making a tent in the shape of a triangular pyramid. Triangular pyramids, remember, they'll have a triangle base. The sides will be made of fabric, but he doesn't need any fabric for the base. The height of the face is 10 feet, and the base is 6 feet. How much fabric will he need? Find the lateral area of the shape. So I'm going to have you pause your video, write this problem down, draw the pictures, and then replay the video, or push play so I can go ahead and solve it with you. Alright, so I was so nice to label this picture for you already, but just to make sure you see where I got these numbers, it said in the problem the height of the face is 10 feet, so that's where I got this 10 foot here. And the base is 6 feet, which is across this way. And that would be the same base over here and on this back side too. Okay? So remember, we're finding the lateral area, so we do not need to find this base. We're just looking for the height, or sorry, for the area of 3 faces. So I'm going to color in the ones that I need to find. So it'll help me remember. Whoa, not with that. Let's try this one. So I need to find this triangle, and this triangle, leaving the base out because he's not putting fabric on the bottom. It said in the problem he doesn't need to. So I only need to find the area of the triangle and times it by 3. So, remembering that my area for a triangle is 1/2 base times height, or base times height divided by 2. My base is 6. My height is, I always do that, is 10 divided by 2. 6 times 10 gives me 60. Divided by 2 gives me 30. So each of these triangles is 30 feet squared. So how many feet squared is the total fabric he'll need? He's going to need 30 times 3, which gives me 90 feet squared. Remember, and I didn't solve for the base because I was just looking for the lateral area of the shape. All right, let's go ahead and do another problem. Oh, wait, sorry, we have a stop and check. I want you to write this in your notebook, write down the problem as well as use these sentence frames to answer it. Write your answer. Explain the difference, in your own words, between finding the surface area and the lateral area of the 3D shape. So start with this sentence. To find the surface area, I, and fill in the blank. To find the lateral area, I, and fill in the blank. Okay, go ahead and pause your video and write your answers now. Alright, now that you've done that, you're ready to solve this next problem. I want you to try this on your own. You're going to find the surface area, not the lateral area, the surface area of the square pyramid. So including finding the area of the base. Just to help you get this set up, because it's a rectangular pyramid, you're going to want to find the area of the base. And then you're going to want to find the area of face, which is going to be, use base times height divided by 2, right? And then you're going to times your faces by 4. So, and then multiply that by 4. I don't know where to write that. Times by 4. Okay, go ahead and try that out. Okay, so to find the base, I needed to look at the base of my, it looks like a square pyramid here, so 8 feet. And then I do base times height, so 8 times 8 gives me 64 feet squared. And then to find the height, or sorry, the face, I look at my base, which is 8, my height, which is 9, and then divide it by 2. 8 times 9 is 72, divided by 2 equals 36. Okay, and I just knew that off the top of my head. If not, you could have divided it in, and that would have been fine. Now, 36 is the area of one triangle face, and I have 4 of them. So I'm going to multiply that by 4 now. 6 times 4, 24, 12, 13, 14, 144. So again, I used 36, which was the area of one face, multiplied it by 4 because I do have 4 faces, and they're all the same size. Okay? And then I'm going to just add this 144 to my 64 to give me the total surface area. Which is 208 feet squared. Now, if I would have stopped at 144 feet, this is the lateral area, but because I wanted to include the base for the surface area, I included my 64 feet from the base. All right. If you have any questions, if you got it right, awesome. If you didn't, then you need to go back and fix it so that you can see where your mistakes were made. Okay, here's another try it problem. It comes with a little chart that you have to read, but these are the dimensions of the Great Pyramids in miles. So we're looking at miles. Whoops, I thought it was my laser. And they want you to find the lateral area of the pyramid Cheops. I don't know if I'm saying that right. So find it on the chart and see if you can solve it to find the lateral area. Remember, you do not need the square base. You just need to know the 4 faces for a lateral area. Go ahead and try to solve that now. Okay, so for the pyramid Cheops, I'm looking in my chart, and here I found it, Cheops. The side length of the base is 230, and the height of the face is 180. So we got some pretty big numbers we're working with here. I'm going to label this as 280, and then the height is, oh, sorry, that was the wrong number. 230, and the height is 180. And I don't need to find the base, so I'm just looking for 4 faces. So I'm going to have 1/2. Actually, I'm going to do divided by 2 because that's a little easier for me. 180 times 230. Divide that by 2. I'm going to do 18 times 23 and add some zeros. We'll just throw zeros in here now. Okay, sorry. Let me solve this real quick. I'm sure you did this just fine on your own. 2 times 8 is 16. 2, 3. Okay. Oh, that's a big number. Wow. 41400 or 41,400. Pretty big number. Now we need to divide that by 2. Make sure I get all my zeros in there. Divide it by 2. 2 goes into 4 twice. 0, 7, and 0, 0. So 20,700. But remember, that's just for one. These are huge pyramids, boys and girls. If you think about it, that is a huge pyramid. So then I need to take 20,700 and times it by 4, because there's 4 of them. I wonder if I can delete some of this. Sorry. Get rid of. Oh, I don't want to get rid of all of that. Okay. We'll just see if I can make it smaller, maybe. Okay, I just needed a little bit more room. Now I'm going to take this number and times it by 4. Okay, which gives me 82,800 miles, which I got from right there, squared. Wow, that is one big pyramid. And that's just the lateral face. That doesn't even include the base, which would be another huge number. This actually, in the book, you can keep going and solve the other two pyramids, and then it wants you to compare to see which ones are bigger. If you have some free time, you can go ahead and do that, because that's an awesome activity to do. But I'm sure my video is getting pretty long, so I need to move on. Alright, one more problem. In this last problem, I am building a sand castle. It is the shape of a triangular pyramid. The area of the base is 7 square feet. Each side of the base has a length of 4 feet, and the height of each face is 2 feet. What is the surface area? Now, notice you're doing surface area, which includes the base. But notice, in this problem, I already gave you the area of the base. I told you it was 7 square feet, so you already have this information. You just need to find the area of the faces, which will be the same. Go ahead and solve this problem. Okay, so I hope you drew this, what's this called, a net, in your notebook and labeled it. The base is 4 feet. Let's see, I'm going to change marker here. The bases are 4 feet. And the height, this is obviously not to scale, is 2 feet. So I would do base times height divided by 2. The base was 4. Height was 2. 8 divided by 2 equals 4. So my faces are all 4 feet. I already have my base, which is 7 feet squared. So these are all feet squared. Add those up. 4, 8, 12. 12 plus 7 is 19 feet squared. This one is on your homework, so I'd probably use this answer because you already solved it. Alright, lots and lots of practice with area of pyramids. Make sure you do your homework and your reteach pages, sharing shows, whatever you're doing for your appetizers. If you have any questions, please ask me. And I hope you guys have a great day.